Hi everyone, welcome back to the channel. I'm going to start a video series on data structures with hands-on, and this is the introductory slides, introductory lecture. In this video, we are going to know what are data structures, what are their benefits, and what we are going to cover in this course very briefly. So talking about very briefly what are data structures. So in general sense, any representation that is used for storing information is called data structure, right? You store the data in the successes of memory chunks, successes of memory slots. That's a data structure. You combine the collection of some data of a certain particular person. That is a data structure, right? There can be many examples: integers, structures, classes, linked lists, stacks, trees, etc. So more typically, a data structure provides a way of organizing for a collection of data items. Like I previously mentioned, that if you combine a collection of data of some particular student, let's say, that is going to be a data structure. So in this course, we are going to learn how to do that. Next thing, where data structure is helpful. So the choice of efficient data structures makes a difference, that whether your program is going to run in few seconds or is it going to take multiple days, right? So the choice of suitable data structures creates a difference in the execution of the program, because you are dealing with the data, you're assessing the data, you're doing some performance, some operations of that, and the way you do that affects the execution time. Okay, so what is actually data structure efficiency, right? A solution is said to be efficient only if it solves the problem within its resource constraints. So there are two resource constraints in general in computer science. The first is the spatiality, means space, or the second one is the time it takes, right? We are going to talk about these two parameters when we will be talking about any of the data structure. So the cost of a solution is the amount of resources that the solution consumes. Okay, so what are actually the cost and benefits? So each data structure has its own cost and benefits. It is very difficult to find a data structure that is better than the other in all situations, right? So you have to make choices, or you have to make trade-offs of selecting a data structure for particular problem, right? A data structure requires three things. So first is space for each item it stores, right? That's the first thing, and that's an obvious thing. The second is time to process each basic operation. The third is the programming effort. Okay, so let me explain with a very brief example. Although I'm not expecting that you already know about linked list, but I'm expecting that you know about arrays. Okay, so in the case of arrays, data is stored in sequential data blocks, okay, one after another. But in the case of linked list, the data is not stored in this way. That linked list has basically the nodes, and those nodes can be placed anywhere in the memory. Okay, so that's one benefit of linked list, right? In the case of arrays, you need to have a fixed chunk. Okay, let's say if you want 100 units or 100 data points to be stored in the memory, you need to have successive 100 memory slots. And the problem is, in some cases, you may not have that memory slot available. Okay, but you may have some memory 100 memory units available, but that is not on one location. So in that case, you would be preferring linked list. But there's a benefit to array. You can directly assess the particular basically memory block or index of the array in one o time. Okay, big O notation of one. But that is not the case with linked list. In case of linked list, you need to traverse all the entries one after another to reach that particular data point. So let's say if that point, the data which you want to assess is on 100th location, you need to traverse each and every item. That's going to take 100 iterations. But in the case of array, it's going to be directly pointed to 100, right? The last one. So time requires in this case is going to be 100 times more in the case of linked list, right? So you make choices depending upon your scenario. And talking about the programming efforts, so yes, in some cases we do not have the previously implemented data structures, right? So you may have to implement that yourself, and definitely that requires effort of programming and time. Okay, talking about the goals of this course. Okay, so basically there are three goals. The first, and we are going to learn about the concepts of very famous data structures which a programmer must know. Okay, that includes linked lists, stack, graphs, and trees, and we may discuss some others as well. And we are going to, when we are going to discuss each and every data structure, we are going to discuss the use cases. Means basically we are going to talk about the benefits, like I previously mentioned, the benefits of linked list and arrays, right? And we're going to come up with use cases that when which kind of a data structure is useful. Okay, we're going to talk about that in detail. Lastly, we're going to implement each and everything from scratch in C++. Okay, so the selection of C++ is because I want you to actually get insights of how data structures are working. Okay, instead of just having theoretical concepts, you should basically, I believe that once actually absorbs the concept when he or she implements that from scratch. So usually people prefer Python as a as teaching courses, but I believe data structure is such a hardcore course that requires a language which demands efforts in coding. Okay, and in the case of Python, that's not the case. So although I'm a big fan of Python, but for this particular course, we are going to stick with C++. Okay, so let's talk about an example. I may have given you a brief introduction about this example previously as well. So let's say you have a requirement from the user, okay, and what user wants from you. We want to store, or he or she wants to store an entry of some data, any data. It can be digit, it can be for float, it can be double, anything. We don't know at the moment. But whenever the user wants to store and the user, he or she should be able to store that. Next thing is, at the point he or she does not know how much entries he or she is going to make. So first thing is it's going to be dynamic. Basically, whenever he or she wants to store the data, your program should be capable of doing that. Number two, he or she has no estimate right now, okay, that how much data is going to be stored. The third thing is he or she does not know that, sorry, he or she knows that he or she in future is not going to be having the big memory slots available, big memory successive slots available. So these are the three requirements, and in these three requirements we have to select among the previous knowledge we have, okay, which data structure is suitable. So this makes clear that the linked list is very suitable for this case. Array cannot be suitable. Why? Because the user has not put any requirement of assessing time. Okay, so he or she is happy with any assess time. Excuse me. But the main requirements is it should be dynamic. Okay, in the case of arrays, you do usually do not have the leisure of dynamically allocating memory. Okay, right? Second thing is, well, this is the case in some of programming languages, but not in all. But second case is the hardcore requirement. That second is that you cannot, in future, you know that you will not be allowed to have big successive chunks of memory available. Okay, so all you are left with is to select such a data structure which does not demand such a requirement, and arrays cannot be them. So in that case, linked list is more suitable one. Well, it is very much possible that we do not select even linked list. We may select some other data structure, some complex one, etc., in some uh, complex form of linked list. But anyhow, among the ones we know, array cannot be the case. Okay. Thank you very much for this video. That was just an introduction. In the next video, we are going to talk about linked list in details. Thank you very much.